So today we are verifying trigonometric identities. Okay? Your goal, you'll be able to, and I know this is double two, okay? Verify identities. Verifying identities basically means you're going to prove that both sides of the equation are equal. Okay? And really and truly, to verify an identity, you just need to be able to simplify. Okay? So if you know how to simplify an expression, like what we've been doing for the past 3 days, then verifying will be fine. The only difference between verifying and simplifying is you actually know what your final answer is going to be. It's just you have to get there. Okay? So verifying means to prove. So in other words, you know what the conclusion is. Okay, you know what you're trying to prove. You know what the final answer is. You just have to get there. Okay? That's what verifying means. Okay. Now the next page basically gives you some steps, if you will, on when it comes down to verifying. They're very similar to the simplifying ones. And yes, this is a whole page because it's just different things to look for. Please do not write it down word for word. Try to shorthand it because like I said, it literally is a whole page of strategies to help you verify trig identities.
Are they different strategies?
No, they are literally almost the same ones.
So we can only write one.
Now the first one, true, we haven't done the first one. But it's going to be an equation. So you start with the more complex side. You look at the equation. You're either going to work with the left side or you're going to work with the right side. Whichever one's more complex is always the better one to start with. But these are your strategies to verify identity. So if you need some steps to help you with this, then I definitely suggest that you write this down.
Are you going to give us an example?
Oh, yeah, definitely. Of every single step. So all you're writing.
My question is, can we just pick one that we like the best?
Sometimes you'll have to use one strategy over another.
Are we?
It won't always work depending on what you
We're
do.
getting a photo, right?
Yes.
That's gonna have all the examples on it.
Yes.
So the examples are handwritten.
Correct. So this can take up probably maybe 4 lines or 5 lines above that last hole punch dot if you write super huge. Okay? So you start with the more complex side. One strategy is to use the reciprocal quotient, Pythagorean, and the other basic trig identities. Okay? Clearly, using the identities. Another strategy is you can use algebraic operations such as combining fractions, rewriting fractions, multiplying, or factoring. It's the same thing that we've been doing. Converting the denominator of the form 1 plus or minus u or u plus or minus 1 to a single term using its conjugate, aka use the conjugate. Another strategy, and the second to last strategy is actually one that we haven't really done with because we haven't had an equal sign. But one strategy is you can work with each side separately to reach a common intermediate expression. And the last one, it was the last one I said with simplifying. If no other strategy works, convert everything to sines and cosines.
The last result.
Yeah, the last resort. If no other strategy works. All the examples in your foldable are basically to help you use each one of the different strategies, okay? And they're not in any particular order. It's just so you can see how you can use some of the strategies. So the very first example, when you open up your little book, is using the whole strategy of converting to sines and cosines, okay? Now, if you look at this, remember, step 1 is to work with the more complex side. Out of these two, is it the left or the right? So I'm only going to work with the right side. And when you're verifying, remember, you're basically trying to prove that the left side equals the right side. So basically, this whole right side can be simplified to equal the left side. Yes?
The directions say to convert sine and cosine. Are we converting everything to sine and cosine? Alright,
So that's using the strategy. So basically, we can't use any other strategy first except to convert to sines and cosines.
Oh, okay.
So this is kind of like how to start it off.
It's giving you that first step.
So I know this is my answer, but I'm just trying to get there. all over sine y. Is everybody okay? And yes, I can keep change flip here. So that's going to be sine y over cosine y times
Sine
1
y
over sine.
1 over.
Oh, I do.
Because the sine y is your denominator. So when you flip it, it turns into 1 over that. Then the sine y's cancel out, don't they? So you're left with 1 over,
Which is the secant.
which is what?
Oh, and that's your answer.
And wasn't that what we were trying to prove?
Yes.
Are we ever going to need to manipulate the answer? Like you see the secant, like are there going to be problems where we're going to need to manipulate that to equal the right side?
That's one of the strategies where you work with both sides at the same time. But it's going to be very rare that you have to do that. And to be honest, there's only one scenario when you'll have to work with both sides, and you'll see it in one of our examples. Yes.
So basically, you're simplifying the whole thing.
Yes. That's pretty much what verifying is. You are simplifying the complex side. The only difference, unlike in 7-1, you didn't know what the answer was. Here, you know what the answer is. So as you're doing your manipulations, if you get down and it doesn't look like the other side, you messed up somewhere. Okay? So it's not me telling you, no, you messed up. It's the work. Did you get the other side? Good job. Did you not? Fix it.
You're done.
Okay, so my question was, will there ever be a question where it's not supposed to look like you're supposed to prove if it does or doesn't?
No. Everything will work out.
Okay.
So you won't have to worry about, is this
So
an identity?
But we just technically just put secant y equals secant.
No, because I'm looking for the word. Don't do that.
I mean, see, we already have the answer.
Don't do that.
Okay.
Say we worked out secant, and we put one like that's what I'm so confused.
Like, first off, what all can you really do with this?
You said to put everything into sine and cosine. You can put
Right. But all you would have is 1 over cosine,
yeah.
which means that you have to figure out how would you manipulate this to get back to be tangent y over sine y. Like you gotta be a beast to go
So how
from
would you
here
know which
up
one
this.
to do?
Well, if one of your side is just one term, that's not complex. Here we have a fraction. Fractions are always more complex than whole numbers, correct? So then there you go. That's your more complex side. And like it will stand out. Like if you have one term compared to a fraction with like 3 terms, clearly the one with the 3 terms is more involved. If one's longer than the other, the longer side is the more complex side.
Why was it sine of y over here? If it was keep change flip, I thought it.
I mean, I just didn't put it there. I mean, I thought that was a symbol.
Oh.
Like sine is the same thing as saying sine y over 1. That's why when you flip it and you change it, it turns into that.
Wasn't it already in the denominator?
That was confusing me, but now I see it makes sense because it's one of them.
Yeah, so like this is the fraction line, so this is the numerator, this is the denominator. So do you see what you're flipping? So you're still getting your practice with simplifying, okay? Here's another one. You're factoring out the common term. This is the strategy that you use here. And if you're like, well, how am I supposed to know that it's this particular strategy over all the other ones? Well, give it a try. Try another strategy. I mean, there's not one set way to verify something. There's a short way, there's a medium way, there's a long way. Either way, we're going to get to the same answer. Okay? Now, when we look at this, comparing left side to right side, which one's the more complex side? Very much so, because you have 2 terms, you got a square, you got some multiplication compared to just cosecant y. You can factor out sine. Both of these terms have a sign in common. So that's going to be sine y, and then 1 plus cotangent squared y. Does everybody see where the 1 comes from?
Yes.
Could you also find out after you do simplify cotangent, but that takes more putting all the denominators?
The one thing I'll say about that, if you did it that way, if you turn cotangent squared y into sines and cosines, you'll actually end up not being able to factor out a sine.
Oh, really?
And please ignore this extra random line. You guys know my pen is having its issues, okay? Now, look what you say.
That's one of the.
Equations, yeah.
This is an identity. It has a squared in it, and it's 1 plus cotangent squared y. What does that equal?
That's negative.
Wouldn't it be a negative? Yeah, because it's
Well,
backwards.
Well, is it backwards in the sense
No,
of
it's just flipped.
it's just flipped, right? I think that identity looks like this, does it?
Yeah.
So even though it's 1 plus cotangent squared x, aren't they both still positive? Okay. So this can turn into cosecant squared y. Remember, we're trying to make it equal the right side. Yep, I can change cosecant squared y into 1 over sine squared y.
Shouldn't that be series 1 though?
What?
No, it's sine squared.
It's sine squared
Oh, yeah.
compared to a regular sine.
Okay.
But you can use that to help you realize that, hey, this is sine y over 1. I'm multiplying. So what happens?
They cancel.
This sine y cancels out with just 1 here.
So you have 1 over 1.
Which equals
So it's just making it easier because now you know what the answer is.
Yeah, like, so now it's not like, have I gone all the way? Can I keep going? Yes, yes you can. You gotta make it equal that side.
That's just practice.
Example 3.
That's what it is. That's basically
Okay.
squared.
Here's an example of working with both sides. It doesn't say it up here, but it says it on your paper. You're working with both sides.
Oh.
Okay? Now, the only time you're gonna work with both sides is when you have a situation like this. Okay? What you have is a fraction equal to another fraction, aka a proportion. Okay? Do you guys remember how you solve proportions?
Yeah.
How do you solve proportions? Say again? You cross multiply, okay? So what I'm going to do is I'm going to multiply these two together, and then I'm going to multiply these two together. And what I'm going to end up doing is I'm going to work with both sides until I reach an intermediate common ground. Okay? So that's going to be tangent squared x cosine x equals
question.
question.
Could you just realize that that's a function and then put it into like a function first, right?
Well, 1 minus cosine, it has to be squared. So, yeah.
It has to be squared.
Oh, it has to be squared?
Yeah.
I guess I think I got one thinking that you do that, but that's squared.
Yeah.
So essentially, this is what we're working with, okay? Tangent squared x cosine x equals 1 plus secant x, 1 minus cosine x. And we're working with both sides. This is the strategy. So we're going to work with the left side or the right side first, doesn't matter. We're going to work with the left side until we kind of get down to a point where we can't go anymore. And then we're going to work with the other side, and then hopefully we can get to the point where we got on the other side. Now, I know this is a little piece of paper. So for me, the way that I did it in my foldable was I kind of split the paper, like split what was left. I worked with one side, and then I worked with the other side. Like put one at the top, one at the bottom, so they reach the same thing. So if you're trying to figure out how I'm going to fit this all, I have the handwriting, Ms. Anderson, you failed me here. Or, if you want, you can use that extra space in your notebook beside wherever you're planning to group this in. Your choice. Okay?
Follow that?
Yes, you want to work, we can work with the side first. Yep. Let's work with the right side first. And yes, Luke, you were right on it. We're going to FOIL. 1 times 1.
Why?
1 times negative cosine.
Negative cosine.
Secant x times 1. Secant x times cosine x.
Secant x cosine negative cosine.
Thank you. I didn't say it, but It is a negative.
Those cancel out. Oh, no, they don't. No. Yeah.
Why would it take this line?
Because the negative one attached to the left equation.
No, right?
The secant is being multiplied by cosine.
Okay, I have a question. What are you saying can cancel out?
Negative cos x plus
No, you can't cancel out the secant because it's connected.
Multiplication.
Right, this one's being multiplied with a cosine, so you should cancel this. But we could change our secants to what? Cosines. Bless you.
So hard to keep track.
Well, the downside is for those who aren't here, I can't record them.
Oh, that's true.
Is that an equal?
No, it's the board. It's supposed to be a plus.
I legit put plus or minus.
What do you see?
That just equals 1 on the left or right side.
The cosine x's do cancel out. So I'm just left with a negative 1. Positive 1 and negative 1. So I'm actually just left with a negative cosine x plus 1 over cosine x.
Multiplied by cosine.
Okay, wait. Y'all got some good ideas. It's all good. I want to make sure everyone's caught up. You
Oh, I see.
see what's going on?
You can times it by cosine x.
I can get a common denominator here so I can add them. The one thing is I'm working with each side separately to reach a common ground. So I can't, So, I can multiply by cosine x. So this turns into a negative cosine squared x.
This is really algebraic.
You can add these two together because you have a common denominator. I really want to skip skip a step, but I don't want to lose anybody. I really want to skip a step. I want to skip that step of rewriting this so that it has one fraction. And I also want to skip the step to say, what does the numerator equal?
Negative sine.
Sine.
Negative sine.
And negative.
It is
Positive.
positive.
Positive because
Oh,
Right.
because there's no.
Why would it be positive?
Because that side would be negative, so your sign would still be positive.
Yeah.
So switch over to
It's just the
cosine.
same way.
See that?
What did it?
The cosine's still negative
Just one
and the
minus.
1 is still positive.
They're not.
It's just written.
What if you end it square?
Okay, hold on. You're trying to go ahead. We
Yeah.
haven't even got past this yet.
It's confusing me.
These are the same thing. It's just cosine's written first and then the 1. Again, you gotta be able to recognize that. These are the same thing. It really does. Let's stop here on this side. Okay? I mean, we could keep going. Yes, we can. Okay? But let's start working with the other side now.
Oh.
What can I do?
Change 10.
Like,
Sine squared.
Sine squared. Cos squared. Oh, squared, yeah. Will the 1 over cotangent never be used to look at these type of problems?
Wow.
yeah, if say this was a cotangent instead, we could use. What do you see? You can cancel out a cosine. Cosine here, cancel out with one of the cosines here, leaving us with sine squared x over.
That's convenient.
Wasn't that what we had over here?
Oh.
I was expecting it to be like another super long piece of that.
Usually it usually is like this. Like you just have to simplify the one side just a little bit, but it's the other side you got to do more work.
The more complex side.
Exactly. The more complex side is the side that you have to do more of the work on, and then the simpler side, there's only a few steps to get it so that it looks like the other side.
So you just leave it sine squared.
Right.
No.
Alright, that's it?
That's it for this one.
Very good.
Alright. That was our work rate. Multiplying by conjugate. That is another strategy that you can
Left
use.
side.
Left side,
Because it's a fraction.
because it is a fraction. And even though, yes, you have two terms here, y'all gonna say fractions are hard to work with anyway, right?
Yeah.
So just work, so just give it a fraction.
Actually, addition
No, I was
is pretty
saying
hard.
fraction.
No, addition's easy because they have like denominators.
We're gonna work with that side because it says.
Multiply by the conjugate. Touche.
That's what I said.
What is the conjugate?
1 plus sine y.
So I'm going to multiply, that was a nice one, the top and the bottom by the conjugate. Okay? Now when I multiply, I'm not going to go ahead and distribute the cosine through. I'm just literally going to write it as cosine y, 1 plus sine y on the top. But on the bottom,
You can do it in your head.
Would you have the foil?
you do have the FOIL. So 1 times 1, 1 times sine, negative sine times 1, cancel out.
It's always going to be
Yeah.
the property for the
Yes.
cosine.
Yes, did everybody hear what Isan said?
Yes.
When you multiply by the conjugate, it's always going to give you an identity. Always, always. And it's the inner and the outer term when you FOIL are always going to cancel out. Yes.
So since that's that line.
Okay,
So
So would they cross out?
No, these can't cross out because they're being
And I
added
can
together.
go to cosine squared.
Yes, the bottom can, yes. The bottom turns into cosine squared x.
So then it would cross out.
So then one of the cosines cancels out with this cosine at the bottom. So you'll have 1 plus sine y over cosine y.
break that apart.
Yes, you could. Why can't you break this apart?
Because that one has two.
Oh yeah, because it's adding and it has 2 on the top, so it'd just be
Because
1
it's
over
over one.
It's over one term. So yes, you can separate these as 1 over cosine y
And then you know
plus
that's correct.
sine
Wait,
y.
why would that be 1 over? Oh.
And that's literally
Yeah,
the other
it's
side.
And it's literally the other side, which is secant y plus tangent y.
But I thought it has to be simplified technically.
That is simple.
That is
Never mind, yeah, that's true.
But you see, you basically have the answers there. They're all there. You just gotta get there. And to be honest, if you were still having some difficulty with simplifying, this kind of helps you because you do have like that safety net of the answer. Okay? And then once you really get the practice there, you'll feel more comfortable doing the ones where you don't know the answer. Yes?
Why didn't we do this lesson?
Yeah.
But I feel like we should have done this right after we got it.
It's better to get
But
the
see,
hardest.
now this is like
Yeah.
smooth sailing because you know how to.
You get the hard stuff
Yeah.
out of the way first.
How are you getting rid of this anyway? Like, reading some work.
Go work.
Reading some
Go
work.
work.
What if I was
The answer
$1?
what?
It's like, oh, I have the answer. I know at the end it should. And don't try to play me either, guys. Okay? Like I'm gonna look at your work on
Yeah,
this,
what
and
if
I'm
I
gonna
just
see that like
write much
this
gibberish
line
and
makes
speak
no
in?
sense to get this line. Don't play me.
I would
You can
show
answer
answer
and
plus
then
one
it's like-
equals like cosine.
Doing a bunch of work and then
Yeah.
I know, it's
next to you.
I was like, that doesn't make sense. That makes zero sense.
When you give up.
Another strategy: combine fractions, common denominators. Clearly, you can look and see the more complex side is the. But in order to add these, you need to have a. So I'm going to multiply the first fraction by
Negative.
The second fraction.
Negative
Sine.
sine.
1 plus sine a, and I'm going to multiply the second fraction by.
Minus sine. Oh, so just go up.
So you just fold.
So essentially, at the top here, I'm just going to have a 1 plus sine a,
But
and then I'm going to have a 1 minus sine a.
So it's going to be an
What's the common denominator? 1 plus sine
Cosine.
a, 1 minus sine a. What are you going to do here?
Foil.
FOIL. We just did this literally on the last problem, guys.
1 minus sine squared a.
We're going to get 1 minus sine squared a, which is essentially cosine squared A. At the top,
I thought it has to be.
Yours
Never mind. I just realized that. Yeah, I just realized that.
what happens at the top?
Three.
And 1 plus 1 is?
2.
2. So essentially, we have 2 over cosine squared A, which is
2 secant squared A.
Wait. What is? Oh, never mind.
Can we get the tablet easy button?
questions.
I always have these lessons like perfectly planned out. Like I look at the timer, like in the last one, it's like right there or something. Even with all of our cutting and
In the struggle of hope. Yes.
Yeah, the struggle is gonna be
The struggle. Last example, here we go.
3 years.
We're going to separate, the last strategy is to separate the 2 fractions, which we kind of already did for the second to last problem. Like 2 problems ago we did this. But it is another strategy you can use. What's the more complex side? Okay?
So I have a question. How come in the beginning you would have to cross out? I won't you.
Because it has a minus 1 attached to this. So essentially it's secant squared beta minus 1. So whatever this term is, whatever number this is, you're dividing it by just the secant squared beta. You can't just cancel these and say it's negative 1.
Oh, I think I know what we're doing. I say we break them into 2 separate fractions. And
Yeah.
one of them is cancelled, right?
Yeah, exactly. Break them up.
Good job, what did I do? Good job, Ryan.
The top one is an identity. That's another way you can look at this problem. But for the sake of showing the strategy, you could have used another identity and then changing the sines and cosines and gotten the same thing. It would work.
Oh, it is. It's single squared. Ooh.
But just for the sake of the strategy, showing you this. Secant squared beta over secant squared beta. 1. What's 1 over secant squared beta?
Cosine.
And what's 1 minus cosine squared beta? And this is how you verify identities. Basically, like I was saying from the beginning, you're using different strategies, the same type of ones that you were using when you were simplifying to get to your answer. The only difference, you know your answer. It's the work that I'm going to be looking